to the Electric Homestead.
What do you do when you're producing more solar energy than you can use on a grid-tied system? One answer is to replace a fossil fuel with more electrical use. Get an electric vehicle, an induction range, efficient mini-splits. But we already did most of that. But we're still using propane for our radiant heat system. The Polaris stainless steel boiler is 17 years old and full of mineral deposits from our hard tap water. Check valves and the mixer valve had all crapped up and needed removal or replacement. So it seemed like a no-brainer to replace this system. The Polaris system used one hot water heater for both our tap water and our underfloor radiant heat. While the system worked great for a while, it finally became pretty much unusable. We have PEX piping, in our case 7/8 inch special PEX tubing, going between each floor joist run. An aluminum baffle fans out the heat, and a 6-inch fiberglass bat underneath directs the heat to the floor above. It's great heat with no radiators needed. We cleaned out the lines with the vinegar solution, and they needed it. Lots of sediment was removed. So we put in a standard 40-gallon water heater, hot water heater electric, for our domestic water use, separating it from the underfloor system. What we want now is a closed unit using glycol and soft water to heat our house. So after searching online for an appropriately sized electric boiler, we settled on one sold by Radiant Made Simple in Minnesota. It is a Canadian-made Thermalec, and Radiant Made Simple mounts it on a board with an air expansion tank, an air eliminator, a circulating pump, and a pressure relief valve. All of these components are connected with crimped copper connectors, eliminating most of the soldering. We ordered the 6 kilowatt unit, perhaps slightly undersized for our floor, but in case of a power outage, we can run it with our 7 kilowatt generator. I performed all of the installation work myself. It is complicated, and to get a handle on it at all, you need to break it down into components. I'm fairly skilled in electrical work and plumbing, so that made it possible. Still, I was baffled by the manifold system and had to search many YouTube videos to feel comfortable with the work. As we only had 2 zones, I could have done it without the manifold and saved some money, but I wanted to try them out. They allow you to fine-tune the amount of flow through each zone to even out heat distribution. The more pipe runs you have, each connected to a different manifold, the more even the heat in your house. Okay, here was my problem installing the PEX. This fitting with the O-ring, I took the O-ring off, but it seats up there. Okay, you take the top fitting off. Then that screws on, then you put the compression ring on with the PEX. That's all there is to it. Okay, we're getting ready to fill our system. Here's 5 gallons of glycol. We're not sure if I don't think that's going to be enough. We're going to pour the water in this big tub. I've cleaned it out, but I still see some debris here. I scrubbed it out. A little utility pump. Here's the inlet and the outlet. Water will be pumped in. The utility pump goes through the system. We've got this first manifold open. So we're going to try to fill that manifold. We have a little bit of fresh water in it to just make sure everything went. Here's our discharge in here, and that'll be water that's already in the system for a while. We'll just keep stopping the pump and emptying that. Right now we've got 20 gallons of soft water, We tried to use one that wasn't a spring water that might have mineral content. It was the 5 gallons we put in so far was one of these without the glycol. So we're mixing one of these containers with 1 gallon and 6/10 of a quart of glycol. Let's see how that goes. Here we go. Okay, let's open this glycol here. I'll get gloves. Got this tip, so there's one low point in the tub. I might raise this bottom corner here and make it so it's a little better. Okay. Once most of the air was out of the system, we closed the outlet and finally reached 23 pounds of pressure. Probably the most difficult part for me was doing some soldering. While there are crimped copper connections, there's still some soldering that has to be done to connect the manifolds. You need to put a wet rag around near the pump, take the union apart, and use nap gas, and I remembered how to solder from years and years ago, but it can be tricky. 2 separate circuits need to be wired in, one being a 120 volt circuit to power the pump with a switching wire going directly inside the thermalec. Then there's the 240 volt circuit that powers the boiler itself. You'll choose the wire size and breaker size based on the size of the unit you have. Finally, you have the thermostat and also the gauge that cuts the unit off if the temperature is too high outside. I had some difficulty with the thermostat because I wanted it to run off the unit itself and not batteries, but it ended up being too complicated for me to fool with to make that happen. See, how does this come on? There we go. The unit ran almost all of November because we had really cold temperatures. Our electric bill more than doubled at 1,544 kilowatt hours used for the one house. We had another issue though. We had a runaway dehumidifier that added to the expense. But even after last month's expensive bill, we have over 6,000 kilowatt hours saved up. So time will tell how the unit will work for us. At any rate, we have exceptional heat and a comfortable house, all provided by our excess solar generation.